Listen, last week we went over a lot on how to prepare for first floor elevations, first floor foundations and slab. Someone had asked me to put together a simple procedure list to go back to follow. Now, I put this together, it's the first page of your handout today. And I did this assuming we're doing an auger type foundation, okay? Depending on the job, depending on the details, it may change slightly from what's here, okay? If you have a separate grade beam and a separate slab and it's not monolithic, it'll be a little different than this. So every job is going to be a little different, okay? Do not assume this is the Bible. As I always say, things change, and it's basically based on details on the job. Pile caps, grade beams, all these different details will alter this slightly. But here's just a general run through of what we talked about last week and give you all an idea of how to proceed, okay? When we started these classes, I wanted to stress to everyone, I want you to understand why you're doing what you're doing and not just following a procedure. Okay, so last week we started talking about rebar, we started talking about some cages, and I thought this week it's important to build on the whole rebar concept of building cages, grade beams, forms, things like that, but also go a little bit into concrete. People tend to look at everything but disregard that part. And it's important, in my eyes, that you guys understand what the aspects of the concrete you're using are, meaning the PSI strength, what you use where, why, and even when you go out and buy things on your own, what you should look for, okay? So what I did is I put together a few basic formats for you, okay? To go into, if you guys look at this one, this is a simple, very simple cage for a grade beam, okay? This is built on a stack and then it's installed in place. But this is how you read this, okay? You've got a strap, just like you have here, which is determined. And it'll give you a dimension for the whole beam, but it'll give you things in here. It'll say 8 number 6 vertical reinforced, and then it'll say 3-inch, number 3 ties, 8-inch on center. What that means is for a column, you've got 8 number 6 rebar. Last week I gave everyone a chart that said number 3 is 1/2 inch or 3/8, number 4 is 1/2 inch, number 5 is 5/8, etc. You have to make sure you have a number 6, okay? 8-inch on center refers to how often the straps are. So you have 8 of them, you have a strap, okay? Then again, it says number 3 ties 8-inch on center, 8 inches up, 8 inches up, 8 inches up. In order to do this, they don't build the cage where it goes. They build it on usually sawhorses or something, because what they do is they lay all the rebar out, they paint every 8 inches, and then they assemble it like an assembly line. It's then picked up, put into place, and it goes from there. In the same token, if you look at this drawing, this is actually for a beam on the main floor of one of the projects we have. The reason I took this drawing specifically out is if you look at the cut of the cage, okay, there's like 14 rebar in that cage. Okay? It's not 4, it's not 8. It's heavily condensed with rebar. Now, this forms a problem when you have concrete. Because if the aggregate, and I'll get into the aggregate in the middle, if the aggregate or the stone in the concrete is too big, you're never getting it through all that rebar. Okay, and the rebar, this has to be completely filled in order to fit the design criteria the engineers have put together. So if this had 14 pieces of rebar, the distance between would be this big. If I have concrete with rock in it that's that big, it's not going through. So understanding what concrete you're ordering and how you're ordering it is very important, because for different applications, it will be used you'll need to order a different formula. Okay? We'll get into concrete in a second. I gave you a few details to represent what we looked at last week. Okay? The auger pile leading into the cage, which is the pile cap, which is the grade beam, the slab, and how it transitions into CMU block. Okay? I left you a few of these just for your own reference so that you can look at how these things are put together. All these drawings are from actual jobs that we've done. Okay? In this drawing, there's a grade beam and a slab, which is a monolithic pour. Now, what does that mean? That means that rather than forming the grade beam, pouring it, letting it cure, and then coming back and putting the slab on top, in this case, the grade beam and the slab are poured together. That's why they call it monolithic. It's a single pour. Last week we talked about earth forms, where you don't actually form it with a concrete form, but you dig the ground and you form the beam out of the earth. So it's an earth form. In this case, you have to do an earth form because you can't leave the forms in the ground. So this ties in the slab, the grade beam, and the pile all into one unison. What you'll see on top is a steel beam. In order to put the steel beam in, there'll be an embed. So when the concrete's wet, the embed goes in. This is a standard one. They're 12 by 12, 14 by 14, whatever the engineer specifies. These are Nelson studs, they're called. They're welded directly to the beam. The concept behind this is that this gets poured into the slab. And later on, when you come back, you can take the steel I-beam and you can, not the I-beam, but the column, and you can weld it right onto this plate. Okay? These are put into the ground. Sometimes you'll see them in the wall where you have a steel beam coming out. Okay? It's important you understand what this is. Now, last week we talked about layout of walls and getting the walls laid out ahead of time. Steel beams are going to fit within walls. So when you do this, you have to have a real conscious layout, a real conscious idea, and a real layout on the site of where those walls are going. This being slightly oversized will allow you to move that column slightly when you finally install it afterwards. But you have to get it in the right place. Okay? There are two ways you could put this in. Most engineers like the Nelson stud because it firmly locks it into the column, into the concrete. Some will allow you to get a steel column with a plate in the bottom that you bolt into the ground. It depends on what the engineer has specified for your job. Okay? One other thing you'll see on this drawing, you see a 1/4 inch V noted over here? That's noting the weld and how they want the column welded to the embed. When you get your job and you get that in, that's something you're going to have inspected. So knowing where the layout is, knowing where the embed has to go in, and how the walls line up, all that's important before you pour your slab. Last week we talked about layouts and things that had to be done, and all the underground and all the utilities and everything else that has to go in before you pour your slab. Knowing where the walls are going after you pour your slab is just as important. Because if not, if this is in the wrong place, two things are going to happen. One, it's not going to be over a point load. When they put a column in, it's to carry the load from above that's going to come down. If you're over a wall, that load is spread over the entire footer. Generally, where these go in, you're going to have 4 piles and a cap, or 3 piles and a cap, to carry that load up at a single point. Okay? If your slab is going to crack, if your beam is going to crack, if you're going to have the most stress on a property, on a beam, It's going to be at a point load. Usually the columns between windows, between openings, because that's where nothing is carrying down except those columns. So it's important this is in the right place and that you understand where you have point loads coming down so you know to make sure you're centered over your piles. If for some reason you put the piles in and when you lay the whole thing out, you don't line up correctly with a pile. Sometimes the pile goes in, it shifts a couple of inches or something. It's a 40-foot pile. It's not millwork, okay? If you find out there's a problem, get in touch with your engineer. He will give you a detail, whether it be a rebar detail on how to modify something, extend a cap. He'll give you something to make sure that you're structurally sound as you continue. A common thing that happens is when they put grade beams in around the perimeter of the house, and there are piles in. If that pile is over a couple of inches, sometimes it extends out past the building. It happens. Okay? So in that case, he'll give you a detail. You dig down, you extend what he considers to be a cap over it, and he'll give you a detail to make sure it's structurally sound. Piles are not millwork. The guy's coming in, he's dropping it a 40-foot from a crane, he's drilling it in, it will move. Okay? Generally, they're really good at what they do, but every once in a while, if one goes off, you have to make sure that what you're doing is maintaining the structural intent of what the engineer has planned. Okay, so let's go a little bit into concrete. But you see this? This is what makes up concrete, okay? Cement, coarse aggregate, fine aggregate, and water, okay? There are additives that go into concrete. There are additives we use. Lime goes into it. Sometimes, sand goes into it. Different things are done to help get the strengths you need, okay? There's a chart here, which didn't really print so well, but it'll show you how changing the mix of the concrete will give you added strength, okay? We use an additive called Penetron. Penetron does two things. It makes the concrete ridiculously strong, and it makes it somewhat waterproof. Okay? It's a great additive. We have come back later and cut a slab with Penetron, and a plumber's losing his mind because he's going through bits in his saw because he can't get through the concrete. Okay? Generally, two things you have to understand. Concrete will set up and cure, meaning reach its full strength in 28 days. It will cure to a point before that. When we put up beams, and you guys have all seen this, when they build beams on the upper level of a house and they have posts coming down to hold it, they'll pour it. When the PSI rating, or the test, and I'll go into that in a minute, when that concrete tests for 75% of design strength, you can take those braces out. Okay? What does that mean? That means if you have 6,000 PSI concrete that they've specified, when your test comes back, if you reach 4,500 PSI, you can take those posts out. Okay? Now this is what happens. When you get concrete on a job, every 50 yards, you're going to get a test. Okay? You'll call the engineer, he'll show up with canisters. Okay? And every 50 yards, the guy on site will come, he'll mark these 3 canisters were used at the left pavilion, wherever it is. He'll note the location. And he'll fill up 3 or 4 canisters, just like this. Okay? When they relate to PSI, they're talking about compression. So they put it in the machine that actually presses, and it waits until it pops, like this. And when it pops, that's the test strength. Okay? They usually pop it after 2 weeks, 3 weeks, and 4 weeks. You can call up and request a pop at any time and get a reading. Just so if you're on the job and you're doing a grade beam, you want to take the struts out, you want to take the post shores out, it's getting in your way, okay? Call, ask them, break one, tell me what you come back with, okay? When it comes back, you'll get a form like this, okay? And if you look at it, the form will say 7 days, 28 days, 28 days, whatever, okay? In this case, if you look on the right, it says compression strength 6950. This was only supposed to be 6,000 PSI. It can be more. But after 7 days, they hit 6950, which means they don't have to test anymore. Okay? We go to CMEX. CMEX usually gives us great, really, really great concrete that cures stronger than it needs to be. Okay? But once you hit that test, now let's say you didn't hit 6,900 on the first week. Okay? Let's say the first week you hit 2,500. And the next week they come and they break the second canister. The next canister will say 4,000. Wait a week, what's the next one say? You keep testing it every week until you get the strength you need. There are cases where concrete doesn't test. And at that point, you've got a real dilemma. Because if you have concrete rated for 5,000 PSI and it comes back testing it too, you're in trouble. You got to rip it out. You got to start again. We generally get concrete from CMEX because it always tests higher than what we need. Okay? When you put Penetron in it, when you put lime in it, when you do a different mixture, it will increase the PSI rating. Okay? Before you start, we talked about this last week, the supplier will provide you with this. This is a formula of how he plans on mixing his concrete. This will go to the engineer. The engineer will have to approve it before concrete shows up on the job. So for example, on one of these, it's cement. Okay, it's got how much? It's got manufactured sand, limestone. It gives you the breakdown. It gives you the formula like you're making a cake. This goes to the engineer. The engineer will either approve it or disapprove it. And if he approves it, you order it. So you get the concrete on site. You've got an approved mixture. It comes. Okay? You can't let concrete sit. If it gets to the site, it's got to be poured. There's only like a 3-hour limit from the point it leaves the yard to when it's got to be poured. Concrete will also cure very quickly. It'll harden, it won't cure. So by the end of the day, you can pull the forms out and walk on it because it gets hard that fast. When you get it, if you see this, this is the engineer's marking of what it is. Okay? He'll pop the concrete out of this cylinder and he'll put it in the press. Guys ready? So this is what we did. We went to nutting. And I said, let me show these guys exactly what this is so they understand. So this is the press. You got sound on this? The cube comes out of that disc, goes into the press. Okay? The computer will start to press it down. 5,000. And it'll do 2 of them. There's one here and there's one in the adjacent. So as it's pressing, the computer is recording. Do you hear the pop? That was the first one. That was that one. Okay? Now watch this one. There it goes. You started to disintegrate. Done. That's it. From that, they developed this report. It tells them what it is. You'll get a reading back that says, this cement, which was used on the North Terrace, has a PSI rating of X. I can call them up and I can say, break cylinders for this thing and give me a call back and let me know what it is. Okay? I don't have to wait for this to come back. I can call them and they'll call me back a half hour later after they put it in the press. This is really important, okay? This is what's going to tell you if your concrete is working, but more importantly, it's going to tell you how to continue on your job. If you need to take post shores out, if you need to do things, you can get this information sooner than 28 days. Okay, 28 days just basically means at 28 days, it's reached maximum strength. It's cured. Now, what happens? Okay, this is all good, but let's say you're doing a job and you're going to go to Home Depot and you're going to buy bags. Okay? Can you steal one of these? Sorry. Where is it? I had one. There you go. So you're going to buy bags. Okay? You've all done this, right? You've all gone to Home Depot, bought premix, right? On the premix, it will say, this is 4,000 PSI concrete. I don't know if anybody has ever looked at that, okay? If it's mixed the way it says to mix it, this will reach 4,000 PSI, okay? This one, if you look, will reach 5,000 PSI. When you go into Home Depot, you're not just, or you're going to Lowe's, or you're going to wherever, you're not just buying a bag of concrete. You're buying a bag of the right concrete. You're mixing it the right way. You're never going to buy a bag of concrete and put a structural beam in with it. Just don't ever even do it, okay? Okay, so you have to be able to calculate how much concrete you need. Okay, this is what trips up everybody. Okay, this is the one part of math I'm actually going to give you guys. Okay, and this sucks, but get used to it. Okay, cubic foot. Okay, cubic foot is what?
12 inches, 12 inches.
Right, it's a block, 12 inches by 12 inches by 12 inches. A cubic yard is what?
3 feet, 3 feet,
3 feet, 3 feet, 3 feet. Okay. So when you go to measure concrete, there's a few ways you could do it. Okay, you could do it by cubic inches. Okay, you can do it by, like a cubic foot equals 46,656 cubic inches. You can measure it a million different ways. Okay, if you're going, let's say you have a slab 12 by 12. Okay, that's 4 yards. By 4 yards. That's 16 square yards, okay? Let's say you're making it a foot thick. That's a third of a yard, right? So you get 16 square yards times 0.3 will tell you how many yards you need to build that. Or you could say 144 inches times 144 inches times 6 inches and divide it by 46,564. Okay? Think of it as water in a box. How do you calculate how much volume that water is? Okay? Math is the one thing everybody hates. Okay? And the funny thing is 5 of us will calculate how big something is, and 5 of us will come up with a different volume. We'll be close. Okay? When you're doing a slab, that's 150 feet by 200 feet, and you have to calculate all the grade beams, right, the pile caps and everything else. It becomes a real chore. It's not something you're going to sit down and go, looks like 100 yards. Doesn't work that way. You're not responsible for figuring out how many yards you need on a slab. That's the shell contractor. But you are, in a real world, responsible for going back and double checking it. Does it sound right? Okay, how many times have you guys come up with a job where they anticipate 100 yards and it comes in at 120? Okay, you're doing earth forms. You're not doing solid forms that are a perfect dimension. You're doing grade beams that are 3 feet thick, and they got to figure it all out. When they order concrete, they order what they think they need, but they alert the yard that this may need to be increased. Okay? Very rarely do they use less than they think they're going to need. They always wind up using more. So when you plan, and you plan how much time you need to do this, always plan for more trucks than you need. Okay? You can get usually 12 yards on a truck, give or take. So if you need 100 of them, okay, you need 8 or 9 trucks. If you're figuring you get a truck every half hour, that's 4.5 hours. But if you need 3 more trucks, that's another hour and a half, and then you need time for them to finish it afterwards. Okay? Knowing how much you need is going to help you determine how long it's going to take you. When you have to figure out how long your job has to be open, how long do you need people for MOT to guide trucks in the street? How long is it going to take you to finish afterwards? Because after they finish pouring the slab, they got another 3-4 hours in finishing it. That's important not only because you need to know, but usually the town needs to know because you're only allowed to work till 6, right? So if you say, all right, I have 300 yards I got to pour, it's 25 trucks, give or take, right? Take them every 20 minutes, right? That's 8 hours. You're going to go over your time frame. So if you have a pour that's a large pour, sometimes you have to go to the town. You have to say, can I start early on this date? And don't tell them the day before. You know, next Thursday I have a pour, it's extensive. I'd like to start at 7 a.m. I'd like to start bringing in trucks at 6:30, but not start working until 7. I'd like to work past 6 o'clock at night. And after 6 o'clock at night, this is what's going to be happening. It's not going to be trucks, it's going to be finishers. You have to get these things figured out ahead of time, and that's usually totally based on how many yards there are, okay? All these CMEX and all these other companies, they're really good at getting things to you on time. Sometimes there's a mess up with a pump, and that'll stop you for an hour, and then you have to make it up. But monitoring your time and keeping the town or whoever informed, the town then has to go to the neighbors. The neighbors have to say, is it all right if they start 2 hours early? Is it all right if they work late? Is it all right if they park in the street? Is it all right, whatever? The town's not going to say, sure, go ahead. They're going to call neighbor on the north side, neighbor on the south side, and say, they want to do this one time. Can you do it? They may say no. You also might wind up at a time where they will, like when there was a shortage last year during COVID and during everything else, and you couldn't get 300 yards, you can only pour half a slab in a day. If that happens, now you've got another problem. Now you have to say, all right, what's the implication of pouring half a slab? Okay, I'm going to have a cold joint between the two sides, or I have to pour all my beams and not pour the slab. Whatever it is, you have to run it through with the engineer. For example, we were doing 980, we can only pour up to a point. We had to come up with a detail for the rebar to extend 4 feet beyond, so that when we put the two slabs together, they were linked with the rebar. We had to get a drawing that said how long the rebar has to be, how far. In some cases, it has to be galvanized, because if it's going to sit, they don't want it to rust. Okay? All these things are important. This is why I say I want you to understand why these things are important. Why is it important to get the right mix so it gets through all the rebar? Why is it important to understand how much concrete you need? Why is it important to know the details that are coming up or the time frame that happens? All these things impact other things. It's like a ricochet effect. Okay? So, go through these and try to follow through how these are. Okay? We could spend a month just on these types of details. Okay? And we will. Okay? We'll bring in examples, I'll bring in photos. We'll go through all this. But you guys need to look at these and make sure you understand what all these notations mean. Okay? And when you're on a job and you're getting concrete and you're getting forms done, go through that list, see if everything on there is done. Okay? Before the job, 9 times out of 10, it'll be 2 days before the pour, and the plumber will go, you know, I forgot something. Okay? Now you've got your termite spray done, you've got your plastic done, you've got everything done. It becomes a last-minute nightmare. Okay? You will be affected by things. You'll be affected by rain. And after it rains, you're going to have to go dig out all your earth forms because they will backwash. You're going to get affected by rain on days that you pour. Okay? You may set up the day before. Nutting, I need guys for 5,000 PSI, whatever it is, but nutting, I need canisters for 100 yards worth of pour at 7 o'clock tomorrow morning. Okay, 6:30 tomorrow morning, you have a tsunami. You have a storm, you have something. Now you have to cancel it. Okay, you have to call everybody. Okay, it's not uncommon to say I'm going to have a 7 o'clock pour. And with the weather coming, I'll get a call with the shell contractor. We'll talk and say, look, we're supposed to have really bad rains. Do you want to postpone it? And sometimes you do, because you don't want a torrential rain coming down as you're trying to put a finished deck in. Okay, when we were doing 1660, we were pouring the beams out on the terrace, and as we were pouring, we're watching a storm come across the intercoastal and watching the lightning come closer and closer and closer. And it got halfway there and everybody jumped off and ran in the house because the lightning was coming and we were all holding on to rebar, okay? These things happen. You're not gonna fix, you're not gonna control nature. You're not gonna control it, but you have to adapt, okay? Understanding how all this works lets you make decisions on how you're gonna proceed, what the implications are of you delaying or changing, okay? Understanding basically lets you look at all the different aspects of this and see what are the implications. If you don't understand everything we just talked about, then when something happens, a rain or a change in detail or something, you're gonna be lost because you don't understand what the implications of that change are. Everybody got that? Okay, take this. I'm very happy to see, like Charlie takes notes. I'm very happy to see people looking at this stuff, following up with text messages and going through stuff. Talk amongst yourself, talk to the supers, okay? If you don't get this, you're not going to move forward. This is it's actually a very complicated thing that becomes very simple after you start to understand it, okay? Make sure you get it. If you have questions, come to any of us. And that's it, all right? Anybody got any? Go ahead.
So as a superintendent, managing these concrete floors is probably the most important thing that we do structurally. So what I do, the people who work with me, is you have to verify what's going in that hole. Meaning, you start at the truck, you look at the ticket, you verify the mix, you take a picture of that ticket, you record it in the Dropbox per area where it was poured, because if you have to go to court to verify that structure, that's the only way you can do that. And so that's very critical. The other thing that you're going to get into, I know Joe ran out of time, but you're always going to be asked, I want to add water. The pump guys are good about adding water, but adding water decreases the strength of your concrete, and then you got a problem. So as a superintendent, you have to sit there and kick some butt sometimes. Then this happened to me Saturday. We were doing the last month on the little slab. The idiot truck driver cleaned out into the pump hopper. I missed it because I was up on the slab. And when they went to shoot the final 3 or 4 yards in,
What?
I had pure water that hit the deck. You have to stop that. I made them clean it out. And guess what? We've lost that curing time before the storm. Here we go. That's all the stress of coming.
When you get, good point, when you get these reports, okay, make sure you keep them. Make sure you give them to your administrative people to put them in Dropbox and save them. You're going to need to hand them over to the engineer at the end of the job. He's going to need to verify before he signs off on the job that this is right. Some of your inspectors are going to want to see it. Okay? I mean, documentation on these things is more important than anything you can imagine. Before you do this, before you go for your structural inspection on your steel, walk it. Make sure they're every 8 inches. Make sure you have 2 inches clearance between the rebar and the form. You know, there are stands that you put underneath these cages to hold them off the ground so the concrete goes under. Some people use concrete block. Some inspectors don't like when you use concrete block. Okay, and you can get held up. If a guy comes out on a day and says, I don't like the concrete block, get me stands, I don't want to see that, you just canceled your pour for the next day. Because he's got to come back and re-inspect it after you make your changes. Okay? Keep your documentation. Just to digress a little bit, there's a second inspection report in here that I somehow can't find right now. You got it with you? Should be at the last couple of pages. There are 2 inspection reports in here. Thank you. This inspection report is if you're doing a footing. We talked about footings last week, and right now we're generally talking about piles. But if you're doing a wall with a footing, which would be, for example, a site wall in front of the street or a slab, they're going to ask you for a compact density report of the soil underneath so that when the thing sits, it doesn't sink. It's on compact soil. You'll call nutting, and it'll give you a percentage of compact that they're going to want to see. This one, for example, which you've all got, took it in 3 areas. 1% of compact here is 100, 99, and 99. This will pass. They usually want 97 or better. Okay? All of these things you need to save. You need to make sure they're marked clearly, they note the area, and you're good. You don't have to save these. You're not even going to see these once they leave the site. But if you don't do these, you're going to have a problem. Okay? Some people will tell you you don't need them. You need them. Okay? I mean, we've all got stories. When I grew up in Long Island, there was a condo complex they put in that they poured. It didn't meet PSI rating. It had to rip the slabs out. Okay? People make mistakes when they mix things too. If you look at the mixtures, it'll give you options how to get mixes for different strengths, depending on what you're using. Like we use a sidewinder mix, very small aggregate, when we're doing things with tight rebar, where it's hard to get through completely and make sure that the form is completely full. Okay? All these things have to be discussed early. Okay? And sometimes there'll be two different mixes within a pour. For example, you'll pour the grade beams with one mix. And then when you pour the slab, they'll bring different trucks in during the same pour and pour with a different mix on the slab. Okay? You'll meet your shell contract, you'll sit down, you'll organize it, you get it done. But a slight change in weather can change everything. All right? Anybody got anything? Look over your drawings. Study this stuff. I mean, it doesn't take long to go through this. It's not a matter of being a brain surgeon with all this. It's a matter of understanding what you're looking at. And as time goes on, all these things we talk about will start to come together. Things will start to make sense in how they work into each other, because everything is like one big puzzle. Okay? You have to understand all the parts of the puzzle. If you understand what happens here, you'll understand, oh God, if I missed a pipe, what do I have to do? Now that you know how this is going in, you'll understand what you have to do. Okay? Thanks, guys. Let's go to meeting.